So take a look. If you have to pause it and go back and forth, please do so. Otherwise, we're moving on to the next slide. So moving on to division. In this case, there's actually a bit of a typo. This is supposed to be squared. So the equation here should read 4s squared minus 8, right? Because each of these is an s squared. So we have 4s squared, and we have each of these, remember, are worth 1 in value, except being that they are red, they're all negative. Don't know if that's going to show up so well. Hopefully it does. So 4s minus 8, and if we want to break it up into equivalent sets, we end up having 4 equivalent sets. So we can divide that whole total into 4 sections. If we do so, we can then break it down. So then, because we cannot impact the s, we don't have an s in this down here in our divisor, what we end up doing is we divide 4 into 4, which then gives us s squared, which is the same as saying 1s squared. So 4 divided by 4 is 1, minus, and then 4 into 8 is 2. So if we look at each of our sets, we have s squared minus 2 in each of these individual sets here. And so that's what we'll end up with. So you can write it 1s squared, but the more common way of writing it would be s squared minus 2. And this is simply showing the same thing. This should also say squared up here. This should say squared up here. Just a typo. My apologies for that, you guys. Okay. So here we have an equation. We can write it out in this format. If we then here move it into this situation, we can divide each of the sections by 3. So this is 3m squared. For some reason it didn't send very well. Sorry about that. It was like this on the PowerPoint, but didn't load into the program as well. So this should all be squared here. Excuse me. So as we move forward, the first part is just simply illustrating how do we get m squared. So 3m squared divided by negative 3 equals m squared. 3 into 15mn, the negative 3 can only divide into the 15, so that gives us negative 5 here. And mn will just carry through, and then n squared, so 3 divided into 20, negative 3 into negative 21 will give us 7 n squared. So you can write it in this format, but preferably, again, my preference, as I mentioned earlier, is to write it in this format. So then we can look at what happens when we divide into that. So again, squared, squared. So negative 3 into negative 3 will give us 1, 1. And the m squared carries down, m squared. Then negative 3 into positive 15. So negative 3 into positive 15 will end up being negative 5. The mn carry down. And we have negative 3 into 21 n squared. And we have a negative divided by a negative. Gives us a positive, so 7n squared. You could break that down into a bit smaller situations, so you could look at it individually as negative 3m squared over negative 3 plus 15mn divided by negative 3, and then minus 21n squared over negative 3. And so if you ended up in that situation, so negative 3 divided by negative 3 again equals 1m squared plus negative 3 into 15 would be negative 5mn, and minus negative 3 into 21 would be negative 7n squared. And then you have to change the symbols again. So you have m squared minus, so plus negative 5mn is the same as saying minus 5mn, and minus negative 7n squared is the same as saying plus 7n squared. So you can break it down into smaller steps if you wish, and if that's what you need, then absolutely please do that. We don't want you to skip steps and cut yourself short if it's going to inhibit your understanding of the question itself or cause you to make reckless mistakes. So what if we looked at this situation here? What if we wanted to find the length of this rectangle? So we can do the same sort of thing that we did before. So we can also simply create a division question, right? If we had, for example, if we had a square, and then that square, we had an area of 36, and our side was 6, how would we find out what that side was? So we have area equals length times width. We know the width per se, so we know this, and we're looking for this. We divide the whole thing by w, divide by w, and length would equal area over w. Well, that's the same thing we're doing with polynomials. Ultimately, in this situation, so I'm going to erase this first, get it out of the way. And so simply we can change this and set up equations so that we can find that length by dividing the area by the width. So we will make a division statement. So 9p squared minus 27p plus 36 divided by 9. Sorry, I don't necessarily have the nice just writing on this, still learning how to write on this. There, ish. All right, so if we divide this out, we can break this into 3 steps. We'll have 9p squared over 9 minus 27p over 9 plus 36 over 9. So 9 into 9 is going to be 1, and we don't have to generally show the 1, so it'll be p squared, and then minus 9 into 27. 29 goes into 27 3 times, so we get minus 3p, and then plus, we end up with 36 divided by 9 is, of course, going to be 4. So we end up with our final polynomial, and the length of this side here would be p squared, minus 3p plus 4. So that's the length of the side that we're looking for. So this page just shows the same thing that we saw on the last page. Again, these should be squared here. For some reason they didn't save as well. This part in the side square saved okay because it was actually a copied picture, but the rest, these should be squared terms that I've just highlighted or fixed on the page. Okay, so write a division sentence for the following polynomial. So we can see that this is could be broken into like a couple of identical sets. We want to see how many sets we have that will be exactly the same. We can't break this up vertically because we're not going to get anything identical. The third, fourth, and fifth sets would not be the same as first, second, or third. However, if we look at it horizontally, we can end up with 2 sets that are exactly the same. In those cases, being that it's yellow, it's going to be 3. So let's stick with the nomenclature that I just wanted to make sure that this ends up being, so we have a total of 1, 2, 3, 1, 2, 3, 4, 5, 6. We have 6x, and being that it's yellow, it's positive, so we have 1, 2, 3, 4, and we have plus 4. Now, how many sets does that break into? Well, you guys can see on here is that it breaks into 2 separate sets. So we can divide 6x plus 4 and divide that by 2. So 2 is going to go into 6x, 2 will go into 4. We can do that individually or just as a group. So 6 divided by 2 is 3x, and 2 into 4 is 2. So we'll end up with 3x plus 2. We can also, again, do that in the other format, as I said. So you could break that into 6x divided by 2 plus 4 divided by 2, and that allows you to see things a little bit more clearly, potentially. If that does, use that method. If not, use the first or the left side. And so 6x divided by 2 will be 3x, and 4 divided by 2 is 2. So you're going to end up with the same thing no matter which way you do it. It's just which is preferential to you, or which one do you works best for you. Normally with, and so again, here's just simply a visual of that. 6x plus 4 divided by 2.